So if this is the function, there's the derivative. Obviously, we can't make it that simple. So if y is e to the 6x, again, chain rule. What you have is u is 6x, v is e to the 6x, du is 6, and dv is e to the 6x. And actually I don't need, why am I doing that? Sorry. So the derivative of the big function, e to the 6x, is e to the 6x. The derivative of the function you put inside it is 6. So times 6. Now we get 6e to the 6x. Now I did that quick. If I can make e to the x simple, you're going to recopy what you're given, and then just look at the exponent, take the derivative of it, and multiply with that derivative. Any questions?
Does it get more complex?
Does it get more complex? It can. I can have, now if I have x squared e to the x. What is that problem? Describe it to me.
When you try to find the derivative of x squared e, it's hard.
Okay. Not so much. I mean, I want you to think back. What we've already practiced and done, what applies here?
Is it the chain rule?
It's separate functions.
It's not the chain rule in that when I look at the exponent of e, we haven't placed anything in here, but I heard it's the product rule because you have one sort of function, x squared, times another function, e to the x. And so we're going to need the product rule. Now, again, I'm going to do my mental version of the product rule, which is you leave the first, you take the derivative of the second, derivative of e to the x is e to the x, add that to leave the second, take the derivative of the first, and you add them together. So what I have is x squared e to the x plus 2x e to the x. I will say this is one case where it is much nicer to say this is x squared plus 2x, factor out the e to the x, and write it this way. Now, was my derivative this step? Was that too quick for you? again, for me, the product rule is just simply as the way I've described it. Leave the first derivative of the second, and leave the second derivative of the first. And that's how I work through the product rule.
Sir,
Yes.
knowing which root to use just comes naturally after some time, right? Like we don't have to know specifically.
Say one more time,
Like we have the three rules, like the chain part of the quotient rule.
right?
From my experience, everything that we can do with product rule way, most times we can also use the chain rule. No, sorry, no, I'm mistaken. No, I got it. I'm just about to.
Okay. Yeah, I would not agree with what the product rule and the chain rule do have their different uses.
I just
Okay. So if I were to, again, try to complicate this a little bit more, I can say what is, or if y is e to the 2x squared minus 2x, not a whole lot to do there. Again, it is the chain rule because you have a function inside a function. So I do need to know u, to know du, and then I'm just going to take the derivative of the big function, which nothing happens when we take the derivative of e to the x, and multiply it by the derivative of the interior, or the smaller function u, so 4x minus 2, and done. So, any questions there? I'm conscious of our time. I want to talk real quick, and the assignment I'll send you, I'll give you some problems to do, as well as try and give you a couple more examples. But, so if the derivative is e to the x, as your formula booklet says, the integral of e to the x is e to the x plus c. And so now it's a question of, how do we do integrals with exponents? And let's start off with the integral of 2 e to the negative x. Now, when I look at this, again, here's the one sort of catch. This x is not x, it's negative x. So you do have to think a little bit about substitution by parts. So you have u is negative x. du is negative 1 dx. We have the 2, so if I want this to be 2 dx, I need to multiply by negative 2. So this is positive 2 dx and negative 2 du. And so now I have 1 over, or sorry, thinking of logarithms again, e to the u du times negative 2. And e to the x, I forgot my dx, comes out. So this is negative 2 e to the u plus c, where u was negative x. Questions? I'm pausing to let you look that over. No? And let me give you one more example. And I know our time is essentially up. If I have 5 e to the 2x, again, I'm looking at the e to the x, and I've got something inside for the exponent. So u is 2x, du is 2 dx. I need it to be 5 dx, and we talked about this the last time. The way I think about what should I multiply to get 5 when I have 2 is first divide by 2, cancel it out, multiply by 5 what I want, and there's my fraction that I need to multiply by. So I really have 5 halves du equals 5 dx. And again, I'm back to having the right pieces I need to do the substitution. So I have 5 halves e to the u du, and integrate 5 halves e to the u plus c, resubstitute there. I will say this step that I'm writing here, again, you're talking about, if you don't write this down, is this worth a mark on the exam? No. Because it would be implied that if you just went from here to here, it would be implied that, yes, you substituted, you took the derivative or the integral part and put x back in for u.